What is overfitting in machine learning models? Imagine teaching a student to solve math problems. If they memorize every answer without understanding the concepts, they might do well on practice tests but struggle with new questions. That's similar to what happens in machine learning when a model learns the training data too precisely. It memorizes not just the true patterns but also the noise and random quirks in the data. This is called overfitting. Overfitting occurs when a model is too complex compared to the amount or variety of data it is trained on. For example, a very deep neural network with many parameters can fit every detail in the training data, including irrelevant details or outliers. Think of it like fitting a very flexible rubber band around a set of points. It bends to match every point perfectly. But when new data comes in, the model struggles because it has learned the noise, not the actual pattern. One clear sign of overfitting is when the model performs extremely well on the training data but poorly on new, unseen data. If your model gets 90% accuracy on training data but only 50% on test data, it's probably overfitting. This means it has learned the specific examples too well, rather than the general rules. To prevent overfitting, data scientists use several tricks. Regularization adds constraints to the model to keep it from becoming too complex. Cross-validation involves testing the model on different parts of the data to see if it performs consistently. Simplifying the model by reducing the number of parameters or choosing a less complicated algorithm also helps. Increasing the size and diversity of the training data is another way to teach the model the true patterns rather than noise. Understanding overfitting is important because it affects how well a machine learning model can work in real life. For example, in artificial intelligence tools like ChatGPT or image generators like DALL-E and Midjourney, avoiding overfitting ensures they produce accurate and relevant results. If these models overfit, they might just repeat what they saw in training, rather than creating new, useful outputs. In short, overfitting happens when a model learns the training data too well, including its mistakes and quirks. It makes the model less useful for new data. To build reliable artificial intelligence systems, we need to find ways to prevent overfitting and make sure models learn the true patterns in data.